Alright, so the first thing I'm going to do is I'm going to import my textures. I'm going to go to Import, click on Desktop, select my textures. Alright, so let me create a material now. So I'm going to right click, Material. I'm going to name this M underscore bathroom tiles. Double click and throw my textures in. Now there's one thing that we need to do. We're going to need to go inside the grayscale textures and we need to change our options to sRGB. So if I go into roughness, double click. Perfect. So I already did it for us. So just note that you need to disable sRGB on grayscale textures. So I already did it for us, so that's perfect. Let me open up another texture. Same thing, perfect. Alright, so we're good. So this is what I'm going to do, guys. I'm going to select on my roughness, going to plug it in. Going to get my normal, plug it in. Now I'm going to get my base color and plug that in. I'm just going to leave my height map here for now, just so we can see a preview of this. Alright, not bad. Now what I'm going to do is I'm going to create a UV system to change the UV so I can apply it on the surface. So if I hold down U and left click, I'll create a texture coordinate. If I hold down M and left click, I'll create a multiply, and then I want to create a parameter that I can multiply and change its value. So if I hold down S and left click, I'll create a parameter. If I select this parameter, I can rename it, and I'm going to name it to UV. Oops, accidentally deleted it. So I'm going to press, I'm going to name this UV tile. I'm going to name it UV underspace tile. I'm going to set the default value to 1, and I'm going to plug that in. And I just have to plug this into all our options here, just like that. Hit apply. And now what I can do is if I select this, I can right click on it and create a material instance. And I can throw this onto my surface. If I double click on this, I can pull this window apart. And what I can do is I can alter the UV set. Because right now it's huge. But you can see that we can increase it to make it much more smaller. Press play. And there's our tile set. It's very wide. In fact, we can easily fix that. We can easily just change this plain texture here and use a multiply. So if I hold on M, plug that in, hold down V to create a vector parameter. This is a color node, and I can name this color. And I can plug that in. I'm going to set the default color though to white, because white is always 111, and 111 always returns the default value of your texture. Alright, perfect. So if I did want to change the color of these tiles, I definitely can. I can make it darker. I can change the color if I want to.
It looks like it's changing the color of the stuff in the middle as well.
Yeah, and the reason for that is because I don't have a mask. But what I could do is, technically I could do this, so it wouldn't look as bad. but I could do this. I could use this height lerp because it kind of does look like a mask in itself. I could use this as an actual mask. So if I create a lerp, if I hold down L, left click, I can run this through that. And what I can do is I can plug this one into B. And now what basically this happens is that now I can plug this into A and just run that connection through. So what this happens is that now I can change the color and it shouldn't affect anything. It shouldn't affect the grit. Let's see. Oh, obviously it's off. So the reason why that's happening, guys, is actually really funny. Is because right now I don't have this plugged in here. So I need to make sure that this is sharing the same UV set. So now that should work. Cool. Now, of course, it's not a perfect mask because it does transition.
You have to export
the mask that we made.
levels thing.
Yeah, that is correct. You would.
Your artistic guide files are supposed to.
But anyways, let's learn how to use the height map. So I'll just keep it the way we originally had it. I'll delete this. Plug it into base color. And now with this, what I'm going to do, guys, is that I'm going to create a node called Paralax mapping. So Paralax occlusion mapping. Now you can see it's massive. Now the way this works is that you want to plug in your height texture into this. However, I'm going to just deattach this UV. It's going to hold down Alt, left click. If I select this object, you can see if I try to plug it in, it doesn't actually plug in under height map texture. The reason for that is because you actually need to convert this into a texture object. It's very easy. Just select this, right click, convert to texture object. If I run this through now, connects. Now all I have to do is I'm going to get these UVs. In fact, I'm going to grab this, I'm going to move right back down here, and I'm just going to alter this. I'm going to plug this into UVs here. That way now everything's combined. I can just grab these Paralax UVs and plug it into all my selections here. Now we're just going to use the default settings. Normally you should plug in a whole bunch of parameters, but because we're kind of running out of time, I'm just going to leave these empty and use the defaults. Going to plug that in, hit apply, and then we're going to see if we have any bump information. So what Paralax mapping does is that it pretty much combines all your maps and it creates elevation.
Now, is parallax mapping also typically done in Unity, or is it just typically done in Unreal?
Oh, usually always on Unreal. That or CryEngine, but I don't believe Unity supports it yet. So guys, it might be a little bit hard to tell, but it is doing it. What we can do is that if we want to see more results, we can create parameters. We have some time, so let's create some parameters. So if I hold down S, left click, I'm going to plug this into the texture ratio. Now, I always recommend every time you're going to plug in or create a parameter, always name it the exact same name so it doesn't get confusing. So this, for example, I will name this height ratio. And I want to set the default value always. The default value, I can just hover over this option, and it says the default value equals 0.08. So if I select this, default value 0.08, plug that in to my height, and I can hit apply. Now if we go to our instance now, we see our height ratio, and I can left click and play around with that. Now it's actually not working because I actually have what I have is that on the floor I actually have the actual material. Actually I have the instance. That should be working. I thought it was the main material I had. Let's see, maybe I can see it better in here. Let me change this UV set so it's a lot larger. Alright, let's see why it's not working. Parallax UVs. Ah, perfect. So the reason why it's not working, guys, is because right down here under height map channel, you can see if you hover over it, it has default value 0001. So what that means is that it doesn't know which channel your height map is located in. Right now, this is an actual texture, so it's currently located in R, G, and B. Right now, the default setting is looking for 0001, which means that it's actually looking for the alpha channel. So to change that, we need to create a 4 vector. So if I hold down 4 and left click, you can see now this is set to 0000. I want to specify that's using an RGB value, not the alpha. So if I plug this in to height map channel, I can double click here, and if I set R to 1, it means that, hey, on my R channel is located my height map. So if I hit apply, it should be working now. I reset that. Okay. Oh yeah, it's working. Let me set a value to 0.01. Now it's a bit too off, but if you look at that, you can see that there's depth. And this is just a plane. This is just a plane, guys. But you can see that that looks like there's actual depth. So if I throw that onto my surface, let's see how that looks like. It's going to look kind of weird because it's massive. So I can change this with my UV tiling. Press play. So you can see that this is actually an illusion, which is cool. This is like the new normal map, so you're going to see this a lot more in the future. But if you zoom in too closely, you can see that because this is plane, it starts to break. A little bit. I think it's because we did this so well, it's really hard to break. This is actually a pretty good example. So the cool thing, guys, is that you can use this method as well. You can use this. I can use this map because technically this height map, it actually will work very well for an AO map. Because if you look at this height map, the natural shadows would actually go in between. So if I grab this map, if I open this up, I can grab this map, convert it back to a texture sample, and I can plug this in to our ambient occlusion. And what that'll do, if I hit apply, I gotta make sure I run my UVs as well onto the AO. Make sure to always get your UVs and plugged in, otherwise they won't line up. So now we have shadows in between. Now these are light shadows, but you can see they're a lot more noticeable here because they always get override. But you can see that looks a lot cooler. I can just easily double click on my instance and I can easily just readjust this. Massive, smaller. And let me play around with my height ratio because right now we have quite very deep tiles. Let me change this to something a little lighter. There we go. Now, of course, one thing that I don't like about the shadows is that it is too strong. That it's actually very easy, really easy to fix. You just have to multiply this. So if I hold down M, left click, run this to the connection, I can now use a parameter. So if I hold down S, left click, I can name this AO, set the default value to 1, and just plug that into B. Now if I run this connection to ambient occlusion, hit apply, now it should work. You can also play around with this function here, guys, called pixel depth. Now before we play around with this, let me show you the ambient occlusion. If I go here now, I can left click and I can control it on the spot. So I can make it look a bit more realistic. Now, what I can also do here, guys, is that if I go back here, this pixel depth, you can use a pixel depth located right through here. Now, apparently right now this is broken from what I heard from Unreal. Let's actually try, because right now I have the latest version. So let's actually see if this is actually working. But from I know it creates weird shadows. If it doesn't, if it works, it will probably be really, really cool. Let's see. Actually, it looks like it's working there. What it does is that's parallax mapping with shadows. And it does really realistic shadows. Okay. It might be working. Let me see if I increase this so I can see this better. And then increase the resolution. Okay. Maybe not. Either way, guys, something I always recommend when you're testing things out in Unreal is use a snip. Use a snip tool. And with the snip tool, what you can do is that you can just grab a section of your screen, test it out. And then what I can do now is I'm going to try something else now. I'm going to go here. And instead of using pixel depth offset, I'm going to use shadow. And with the shadow, I believe shadow is working. I can plug that into pixel depth offset, hit apply. And we can just do some quick comparisons. Okay, there we go. The more I open it up. Okay, so you can see its slider. I think I got better results with the other one. Yeah, I can tell here. So, with that, we already know what to do. Right through here, go back to pixel depth offset. So that basically helps create virtual shadowing.
So did you want us to parallax mappers?
No. 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 You'll have to do it for the next assignment after that. But there's video series on that. Okay, so that should be all, guys. But you can see how cool that looks. Because we did this in Substance Designer, and because we did it pretty much all with vectors, it's almost flawless, the height map. The height map is nearly flawless to the point that you don't see any distortions on the side. And that's quite hard to get with a height map. Because the height map has to look quite flawless. It has to have nice transitions. If one pixel is off, you would see a dent. That'll look kind of nasty.
Well, I mean, unless you want a damaged wall.
Yeah, unless you wanted a damaged wall. But even then, when you have like noisy pixels, it looks really weird with a height map. This is why when I created a height map, I didn't actually create it with the grout noise, because the grout noise would just like spike out like crazy. You can see that looks like a very nice smooth shape here. And you can see that if you guys look very closely, you can see that everything about parallax mapping is created with planes, because all it does parallax mapping, guys, is that it creates planes for your actual material. So basically, it keeps on rendering the planes, and it's based off the height map. So it's creating a whole bunch of transitions based on the height map, and that's how it creates, you know, a fake silhouette. So it's very interesting.
But it's not like adding polygons, right?
Not adding polygons. So this is the second way you can do a height map. Let's see if I can quickly show you guys tessellation. So tessellation is the second way to get a height map. That's without using this method. So let me just push this aside. So for tessellation, this is what you would have to do. You have to activate DirectX 11. So this is a DirectX 11 feature developed by Microsoft. So if you type in tess, you'll get tessellation here. And if I zoom in here, you can see I have a tessellation multiplier. If I go here, I can click on a different option. Now, flat tessellation means it's just going to create vertices. It's not actually going to change the actual shape of your geometry. Now, PN triangles will change the shape of your geometry. It will actually, if this was a smooth shape, if this was on one smoothing group, and it was like this, it'll create additional vertices to smooth out that shape. So for this object, let's actually create that. PN triangles. So I also want to make sure, actually for this we don't have to click on this, but this crack-free displacement, make sure it doesn't break your mesh if you have UV islands. Right now with this we don't have UV islands, so we don't have to worry about that. So you can see with that, it opens up tessellation multiplier. Tessellation multiplier is just like subdivide in ZBrush. You put in 1, 1 divides it 1 time, 2 divides it twice, 3 divides it 4 times, 3 times, etc. So if I hold down 1, left click, I can create a 1 vector, and then here what I can do is I can select on this, go here, and I'll put in, I'll say 3, just because I know the surface we're playing on this is going to be pretty low. So now we have tessellation. However, we need to make sure that it tessellates the right areas. So we actually want to plug in our height map into world displacement. So let me actually disable all this UV system here. So I'm going to grab this height map, Control C, Control V, and I'm going to plug it into world displacement. Hit apply. Now I might have to use a multiplier with this. That's the one thing I forgot to mention. You might have to use a multiplier. So if I hold down M, left click, plug that in, hold down S, left click, create a parameter. I'll just quickly do this while class is almost ending. Hit apply. Now this is actually creating geometry, so this is going to be quite more expensive, but it might be needed for whichever objects you're using. Tessellation. Tessellation is better for assets. Parallax is better for floors, better for anything long, because basically tessellation is just mimicking, it's creating an illusion. Meanwhile, tessellation is actually creating the geometry. Here we go. So DirectX tessellation actually creates geometry, as you can see here. Now it looks really weird because I do need to make sure that I don't have anything connected to the UVs, which is right here. Let me just connect that. Okay, should work now. So tessellation, real tessellation actually uses a height map and it creates extra geometry. It creates more vertices to pop that shape out. So it basically creates vertices to actually pop out that shape. Now Parallax, what it does is that it creates virtual renderings of your material over and over again to make the illusion like there is depth, but there is no depth. There's literally just a plane.
So tessellation is like actually doing it, Parallax is just big.
Correct. Parallax is more efficient, but it has its limitations. There we go.
Oh, that's pretty.
That's so pretty. So pretty.
Whoa, what are you doing?
So, just let you guys know, there's not enough vertices. Okay, so let's go here. Let's see if I can turn this up to something like crazy. 6.
6 is super crazy. You're a dangerous man.
I like to live dangerously.
I have 2.
So we can see here if I go into wireframe, it's going to pop in and it's going to be like wha-bam. Okay, not wha-bam. Actually, you know what, guys? There's actually a limitation to tessellation in Unreal. I forgot about that. It won't. You can't just put like 10 tessellation and expect 5 million. There is actually a hard limit built into Unreal. So we might have to use either a shape that we make ourselves, but it has to be something with a lot of vertices. Let me see if I can show an example here. Because just to get the very slight silhouette, it'll be very expensive. So we actually have to make sure we have a special mesh. But either way, that's exactly how you do tessellation. It's just that we don't have enough vertices.
Well, if you want RuneScape icebergs, that's how you do
I'm good.
it.
Alright guys, so that's pretty much the end of our lesson.
Thank you all.
No problem.
Thanks, Mello.
See you guys.
So you still want the